x squared, that's this black one. Now look at the green one, see how that looks different. We'll plot some points. So that we can compare them and see how they're the same and how they're different, we'll pick similar x values. Like we're not going to pick 1, 0, negative 1, and then over here pick 17, 13, and 25. It's not going to make it easier to compare the two. So we'll pick, let's say, 5 points. Good ones. This is what we call, this black is what we call the parent function. Because it's the simplest, the most basic way to achieve a parabola when you graph it. Okay, that's one way to look at it. It is the simplest of its kind. Okay? And from there we have what we can call children. Right? They're going to look similar, but slightly different. There's going to be changes. What looks different about this equation?
3.
It's got adding 3, right? Okay, so that makes the equation look different. It's going to make the table of values look different. It's going to make the graph look different. And we can see how those things are different. Obviously, the plus 3 is different from the equation. How's that going to affect the outputs?
We add 3.
Just add 3, right? They're going to be 3 more than what these are.
Yep.
We put negative 2 in here, we square it, we get 4. Okay, we do that here too, we get 4 for that part. But then we add 3, and we get 7. We put negative 1 in there, well that part is 1, right? When we just square it, we get 1, but then we add 3. Add 3 to it, we get 4. Put in 0, 0 squared is 0, but then you add 3, and you get 3. 1 squared is 1, we add 3, we get 4. 2 squared is 4, we add 3, we get 7. You seen that symmetry again?
Magic.
Symmetry. It's not magic, it's math. 0, comma 3, 1, comma 4, negative 1, comma 4, 2, comma 7, negative 2, comma 7. What if we put in 3? Where do you think 3 would take us? 12, right? This function went to 9, and we're just going to add 3 to that. 1, 2, 3, that goes to 12. Goes to 12, so negative 4, what is that? Negative 3. Negative 3, 12. We can connect the dots. Alright, so the equation looks different because we have plus 3. The outputs look different because they're 3 more than these outputs. We added 3 to each of those to get these outputs. How does it change the graph? How does the graph look different?
It's 2 parallel.
It's what? It starts higher. Yeah, that's pretty much it. It just starts higher. It looks the same in every other respect, doesn't it?
Yeah.
Looks exactly the same, only it's 3 up from the black one. Here's a question. Maybe you don't think that it looks the same. Does it look skinnier to you? Is it skinnier?
No.
It is a little skinnier?
Yeah. No.
Okay.
No, it's the exact same.
It is the exact same. It's only moved up 3. It's like if this was a bowl. You have bowls at home, right? I assume.
The
You
stack.
have bowls. You stack them inside each other. Is the bowl that goes inside the other one smaller than the first bowl?
Sometimes.
Not if you have a set of bowls that are the same. They sit inside each other. One is slightly higher because it's inside the other one, but it's not any smaller. They stack it up. Just keep on stacking until the bottom one gets crushed. It's not any
I
smaller.
wonder how many bowls you need to do that.
Alright, moving on.
We're not allowed to have fun in this
Buy all
class,
the
Mr.
bowls.
Stewart.
What's that?
We're not allowed to have fun in this class.
We're just
Yeah, can we do an experiment?
not allowed to waste time.
Um,
Let's go to the blue functions.
We'll pay you for all this time. Happy birthday, John.
Okay. Okay, we're going to try this again. Negative 2, negative 1, 0, 1, and 2. Alright. So, how is this function different?
Now you're gonna do like 2.
You're going to multiply by 2. After you square it, you're going to multiply it by 2. So I meant to write this down over here. This plus 3. Move it up 3. What is that 2 going to do to all of the x squareds?
It's gonna make it go up even higher.
Go up higher? Going to double them. Is it going to move the graph
It's
up?
gonna be twice as big.
Twice as big.
Yes.
Skinnier.
Yeah,
Good. These
twice
are all
as
good
good.
descriptions. We're going to take these outputs, right? These are the outputs of x squared. We have those here, x squared. But then we multiply them by 2, so all of these will get multiplied by 2. Right? When you take negative 2 and you square it, you get 4. But then you multiply it by 2, you get 8. Negative 1, you square it, you get 1. You multiply it by 2, it's 2. 0 squared is 0. You multiply that by 2, you still get 0. 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. So, I heard somebody say that it moves it
Out wider.
wider.
Oh, I said that.
Yeah, we've covered both of them.
Well, let's see.
It's gonna be full.
0, 0, 1, comma 2,
Starts with the same black one.
1, comma 2. You see how it's going to go through this point and it's going to be higher than this one? Is that going to be wider?
It'll get wider.
Okay. Negative 1, comma 2. Negative 2, comma 8 and 2, comma 8. 2, comma, not 4, right? This was the output of the black one. That was plain old x squared. Then we multiply it by 2 and we go up to 8. And negative 2 goes up to 8. 8. Positive 3. The output of the original function was how much? And what do we do with that 9? Times by 2. Negative 3, 9, doubles to 18. What doesn't? Which graph? Oh, to 18. That's okay. And then we connect everything.
Oh, that was
So we'll just keep going on forever, or we'll like, even out
What will even out?
the lines. Or,
Oh, did you get parallel?
will they ever just like, or will they keep going out like that?
They will
Slowly
appear to be
forever.
straight, but they won't be.
Right. If you look at them at this scale and you go up and up and up really, really far, then they'll look parallel.
They'll always be going around.
Or are they?
Yeah, a little bit. Right? Because, like, from here to here, let's look at the black one. From here to here, we go from 2 to 3. But 2 squared is 4, and 3 squared is 9. When we go to 4, 4 squared is what?
Isn't that a game?
What's 4 squared?
16.
16. What's 5 squared?
25.
25. What's 6 squared? 36. What's 7 squared? 49. Because we're making these bigger and bigger steps every time we move over one, we're going up by a lot more. 8 squared is 64. 9 squared is 81. 10 squared is 100. We're making these larger and larger steps each time. Does that make sense? So eventually we'll be making such large steps for just to move over of one that it'll look like it's vertical. We could actually we could look at x squared if we have the calculator on. So x squared, the question is, do they ever like, get parallel? Well, we can change the window. Here it is in this basic window. Change the window to move way up on the y-axis.
Negative 100.
We want to move up
100.
100.
200.
300.
1,000.
Oh my goodness, that was
Let's move it to 1,000.
Okay. Well, now we have run out of space this way.
Let's move both of them to 1,000.
Right, so we're gonna move. We can move the x values to, let's say, negative
1
100.
billion.
We'll start out slow here. Okay, and then we need a y value that's big enough to see that, so we'll go 10,000. Okay.
That was cool.
Let's see. Well, let's see. Let's stretch out our window to
Infinity.
negative 1,000 and 1,000. And let's see.
Billion.
$1 million.
Billion. Trillion.
Infinity.
Well, I would say
Yeah, 1 billion.
Does the calculator even handle infinity? Okay.
See, what's happening is the graph is so skinny we can't even see it. So let's go back into the window. now you can see it.
It's like a roller coaster.
Which
Almost
designer
like
of roller coasters using calculators?
Put another 0 here.
That's cool. I want to do this now.
Oh, no, that's thinking the wrong direction. That flag for that. Go, let's do. You see how it's. You see, it's very, very steep. So, if we just keep going up like this and viewing the parabola, it'll look steeper and steeper and more like it's vertical, but never actually getting to be vertical.
So what are these used for? In real life?
Used for?
Yeah, will we ever use these?
Every day of your life we use these.
Every
That's the
single
important part
day.
of this
What are they
class.
used for?
Name two instances.
It's area. If you have the area of a square is going to be x squared, where x is the side of a square.
I really just figured out the graph square.
Well,
Hey,
yeah,
how
why
did
don't
you
we
get
need
it to
to
do
graph
that?
it, though?
Later.
I can't get it to do that.
That's not the goal of this class.
But I wanna
to
know now.
entertain you. What did this 2 do to the graph? Skinnier. Can we use the word steeper?
Sure.
The reason why I want to use the word steeper is because it has carried through all the way into calculus.
So if you did a
Gosh,
negative.
you're really steep.
We'll talk about what would happen if you were negative.
Just a little.
Really want you guys to pay attention and let's get ourselves under control. Okay? So stop talking about other things. Just pay attention to what I'm talking about. All right. So when we multiply x squared by 2, it doubles every output and therefore makes the graph steeper. That concept of steeper, if you can conceptualize the idea of this being steep and more steep, then that's a concept that we really dive into in calculus. So I just want to put that word in your heads, making you think this is steeper than this graph. When I look at this same x value and I look above here, this is much steeper than this is. How much steeper is it?
3 times.
How much?
2 times.
2 times steeper. Pretty straightforward. 2 times steeper.
What if it was 2x cubed?
We're not looking at cube today for a very long time.
You can't cube it. It's impossible.
It's a good question. We're gonna concentrate on functions that are x squared, not x cubed.
If we're not looking at it, can we still hear about it?
If we have time at the end of class, sure. We'll also next chapter is about x cubed and all of the other x's to all the other powers.
Or
So 2x squared is 2 times steeper than x squared. We'll go on to the red one. So we have x squared, and then we multiply by 2. What's that 2 going to do?
Make it steeper.
Double it.
2 times steeper. It will double every output.
Steeper or word?
Yes. It just increases more steeper. You know, when you go up a mountain that's not steep, it's steeper than the other mountain.
What is
I think that's the best way to explain it.
what is this going to do? What is adding 3 going to do?
Make it go up. Like this.
It's gonna make you go like. It's gonna make
Higher
it
up.
start higher.
Start higher, going to go up 3. Right? Start higher, start 3 higher. So it's both going to be twice as steep and up 3. Start 3 higher. So if we put in these same values for x, well here we have it's doubled, right? So we have all of these outputs. Does that make sense? All of these outputs are from the blue function, which is just 2x squared. So here's 2x squared. Negative 2 squared times 2, that's 8. And then what are we going to do with 8? Add 3. We have 11. And then negative 1 will give us an output of what? 5. 0 gives us an output of 3.
5. 11.
Good. 0, comma 3. 0, comma 3. What's this point called on the parabola? The vertex. Very good. And 1, comma 5. Negative 1, comma 5. 2, comma 11. 11. Negative 2, comma 11. And yeah, that's going to just really start taking off. So does it look the way we expected it to look?
Yes.
No?
Like we said, it would get wider. I don't know why, so I was thinking,
Oh.
don't listen.
Well, we said it would get steeper, right? Multiplying this by 2 makes it steeper. Multiplying by 2 makes it steeper because every value is twice as high when you compare it to just x squared. Right? This is twice as high, and this is twice as high. So it's getting bigger faster than the black function, or even the green function. The green function is just as steep as the black one. How could we make it even steeper than that? 50. 50 would make it very steep. Steeper than 50.
1,000.
51 million.
1 million. These are steeper. A million times steeper, and a million and one times steeper. How could we make it less steep? How could we make a new function that's less steep than this black one?
Negative.
Let's try negative.
Negative 2.
F of x equals negative x squared. Now keep in mind, when we put a negative in there, the negative is after you square, right? It's not before you square.
That means everything.
Everything will be negative, right? Remember we said there's no way to get a positive out of this, or a negative out of this? Remember how we said that? All these will be positive? Do you remember that? Yes. Okay. So when we multiply all of those things that have to be positive by a negative, all of them now will be negative. And we put an x and look at the output. Look at negative 1, negative 2, 0, negative 2, negative 1. Or sorry, not negative 2, negative 1. 2 and 1.
1, 2.
Fine, 1 and 2. When you put negative 1 in there, we square negative 1. What do you get when you square negative 1? Not this, just negative 1 squared. 1, and then you multiply by negative. Negative 1. Square negative 2. 4. 4 multiply negative and negative 4. 0. 0. 1 squared made a negative. Negative 1. And we get negative 4. So what did putting a negative in front do? Upside down. Reflection. That's good too. Good words.
Well done to the
It's an hour and a half.
Okay. So this negative reflects, we could say it reflects vertically. It takes it and it moves it, it reflects it vertically over its.
How do we reflect it horizontally? Would you have the same thing?
Yeah, very good. Yeah, it has that vertical symmetry, so to flip it horizontally, it would look the same. So there's really no
Can you move it off the y-axis?
Well, like these two are off the y-axis, is that what you mean?
Or can you move like the whole, the one to the right?
Yeah, we can move it to the right, we'll do that a little bit later today.
He's crazy.
There are ways to do that. Okay, think of it this way, it's just as a preface to that question. When we add 3 to the output, right, we square something for x and then we change the output. We add 3 to the output. We change the y, right, the vertical. Does that make sense? So we change the output, we change the y, we change the vertical aspects of the graph. So if we wanted to change the horizontal, we would want to mess around with what? Not the y, the x. So we want to do stuff to x before we square it. Change the x. When you put something in for x, change it first, then square it, and see what happens. We'll do that in a little while. putting a negative in front of x squared will flip everything upside down. It'll reflect it vertically. But back to the question that I posed originally was, how do we make it less steep? How would we make this less steep than it is? Less steep than this black one?
Could you lower it?
That would make it less steep, though.
Divided by a number.
Instead of multiplying it by 2, how about divided by 2? Make everything half as big. How about divided by 3? Make everything a third as steep. Okay? Does that make sense?
Kind of.
Okay. Well, let's look at
It's like 2/3 this one here.
2/3, right? That would make things smaller. We'll use a simple example here. We'll just use 1/2 to start with. 1/2 x squared. Remember how 2, multiplying everything by 2 made everything higher up, and so it made everything steeper. So if you multiply everything by a half, that'll cut it in half, and now these points will be half as high as they used to be. 2 -1, 0, 1, 2. So we put a -2 into x squared. Well, that's what we get when we put it in the black function. -2 squared is 4, and then we divide that by 2. We multiply by half, and we get 2. -1, when we square it, this 1, we'll multiply it by a half and get half, or 0.5. Put in 0, you square it, multiply it by a half, you get 0. 1 will give you a half. 2 will give us 2. Okay, so 0, 0. 1 and 1/2. 2 and 2. -1 and 1/2. -2 and 2.
Looks like a rainbow.
It's starting to look like a rainbow, yeah.
I'm not gonna lie, I expected Kyle to say that like half an hour
16
ago.
is 4. Yes. 4 would give us 8, right? 4 squared is 16. But then we divide it by 2, and we should get 8. So I should really kind of redraw this. And we should get -4 going through 8. I'm going to erase those. All right. So it is a lot of lines. It is a little messy now that we've gotten all done with it. So let's go to the next page, and we'll summarize everything we've talked about. We can take x squared. That's your basic, your black graph that you saw. Okay. What kinds of things can we do to change it? To change its graph, to change the output? Add 3. We can add anything, right? We'll just call that anything k. Right? K could be 5. K could be 7. K could be -3. Right? What if it was -3? What would the graph be? Go down 3.
Double it.
We double it. Go down.
Another thing.
Oh, we could double it. Yeah, we could double it. We could multiply it by something. Right? So if that something is 2, we'll double the output. If that something is 3, we'll triple the output, make it 3 times steeper. If that something is 1/2, it'll make it half as steep. What if that thing is negative? Makes it go down. It flips it over, it reflects it vertically. So this guy here moves. Well, yeah, it does change the y intercept. It moves it up or down. When does it move it up? When it's positive, it moves it up. When does it move it down? When it's negative. Okay. Okay. So this, what is this? What effect does this have?
Makes it go up and down, like it, like
Steepness, slope. Yeah, yeah.
makes
Now the interesting thing is that the idea of a curved graph having slope. Right? How do you normally look at slope? It's just rise over run, right? But like we can look at the rise over the run, but that's not really there's not a slope. The slope would mean if it had a slope between these 2 points, it would go straight. Does it go straight? It doesn't go straight. And the idea of a curved graph having slope is a calculus idea. It's the first idea in calculus that we talk about. We don't have to worry about it today, but there is a slope of the graph at this particular point, and But yeah, that number out in front affects the slope of the graph at any point and affects the steepness, we'll say. Okay? It could make it steeper. How can it make it steeper? How about throw out some examples of numbers that would make it steeper? 2, 4, 6, 12. 12.
If it's bigger than 1.
Bigger than 1. I like bigger than 1. Okay? If A is bigger than 1,
1.05.
1.05, does that make it bigger? A little bit steeper, yeah. But what if A is negative 5? Will it be steeper?
Well, there's bigger than
It'll be upside down, and will it be steeper as well?
Yeah.
Yeah, it'll be both, right? It'll be both steeper and it will go down. Okay. Well, so but is like so if A is negative 5, it'll make it steeper. But is negative 5 bigger than 1? It's not. Its magnitude is bigger than 1, right? Like if you looked at how big it is, it'd be bigger than something that is 1.
It's farther away.
It's further away from 0, right? And this is how we say the distance from 0. What's that called? Absolute value. Yeah, absolute value is the distance from 0. So if the absolute value of A, whether it's positive, if it's negative, right, it always comes out to be a magnitude. It's just the distance from 0. So if its distance from 0 is more than 1, then it'll make it steeper. So positive 1, positive 1.05, negative 2, negative 5, positive 7, all of these will make it steeper. Okay. What about less steep? Its absolute value is less than 1. It's a fraction. 1/2, negative 1/4, 2/3, negative 7/9. All of these numbers that are their absolute value is less than 1. Because everything that you have, everything that comes out x squared, you would multiply it by this number that's less than 1, and so it would make it less than what it was worth before. If yeah, and if A itself is less than 0, what does that mean? Less than 0. What's another way you can say that? Negative. What kinds of numbers are less than 0? All the negative numbers are less than 0. Then what happens if A is less than 0? If A is negative? Reflected vertically. Now I want to talk about that real quick. When you say flipped over the x-axis, it's not always flipped over the x-axis. Okay? Let me show you what I mean. It just kind of depends on how you phrase it and how literally you take that statement. Okay? Let's talk about this guy. F of x equals negative x squared plus 2. Okay, so if I take you literally and I take that negative to mean it's always flipped over the x-axis, then, well, what does this plus 2 do? Up 2. Okay, and then this graph would look something like this, right? Yeah, so it's not flipped over the x-axis at this point. Over its own vertex, yeah, it would be flipped over its vertex. So wherever it is, it gets flipped over its vertex. Now we know that that's now if you actually think about this, right? If you take a number and you put it in for x, like 2, you put 2 in for x, and you square it, then you make it negative, right? The first thing you do is square it, then you make it negative before you ever move it up 2, right? So if you square it, then you make it negative, you flip it over, it will always be over the x-axis, just as long as you don't first move it up 2 and then try to flip it over the x-axis. So to be safe, you can say reflected vertically over the vertex. That'll always be true. The vertex. Okay, good. So we talked about that Now, here's the thing. Those are really specific examples where the only things we can do are to multiply x squared by a number and then add a number. We're going to expand this. So we want to talk about every kind or every possible function that's like this function. And like this function means you have an x squared. Right? So we want to expand it to all what are called quadratics. Okay? And all quadratics would include not just ax squared plus k, but ax squared plus bx. Right? A number times just x to the first power. We can do that as well. And then we say plus c. You get a number in front of x squared, a number times x, and then it's just a constant by itself. Anything that looks like this is a quadratic. It's called a quadratic. And specifically, if it's like this, ax squared plus bx plus c, this is in standard form.
Oh. And then you use the quadratic equation thing.
Okay? We will eventually, in a few sections from now. So this is in standard form because it's ax squared plus bx plus c. A quadratic is any function that has the highest power of x that you see is what? How big is the highest power you see? Squared. Yes, squared is the highest power. So now it's not as easy to say, like you can't just say that it moves up by c, right? Because we have this dx. This changes the output. Right? This you square x and then you multiply it by a, and that affects the steepness. But then we also, this makes its own little contribution, and then we add c. So it's not just, hey, it moves up c. So in order to graph a function like this, let's use an example. An example like 22. X squared minus 6x plus 4. First, we're going to want to find the vertex. It's going to make it easier. We can find the vertex. We find the axis of symmetry goes right through the vertex, and we have this reflection of the axis of symmetry that makes it easier to graph as well. So to find the vertex, there's two parts to the vertex. What are the two parts? The vertex is a point, right? It's a point somewhere on the graph. What's that? X plus c? What are the two parts to any point on the graph? X and y are the two parts to the graph, to a point on the graph. Okay? So we need the x part of the vertex and the y part. Okay? So first we'll talk about how to find the x. The x, and when I write these letters down, I'm referring to these letters up here. Negative b, right? B over 2 times a. Negative b over 2 times a. So for this number 22, what is a? It's 3. 3 is a because 3 is the number in front of x squared, and that's what a is. A is 3. What's b? A? Negative 6. What's c? 4. B is the number in front of x. C is the constant by itself. So if we're to find the x part of the vertex, we do negative b. Negative, what's b again? Negative 6 over 2 times, what's a? 3. Okay, so let's clean this up a little bit. We get negative 6 over 6. That's just negative 1. Yes. Oh, yes. Positive 6. Positive 6 over 6. We get a positive 1. Well, that's the x part of the vertex. It's great. It's nice that there's that little formula that tells us that. But we need the y part of the vertex. How do we find the y? the x. Whenever you have an x, this is an x, you plug it in for x. So we can show that by saying, right? This notation just means I took whatever I got from negative b over 2a and put it into f. And so there it is. And so we're going to take 1 and put it into this function. So 1 squared is 1 times 3 has 3. 3 minus, well, this will be 6. 3 minus 6 is negative 3 plus 4. Negative 3 plus 4.
Positive one.
Positive 1. Negative 3 plus 4 is positive 1. There's the vertex. We found both parts of the vertex. We found the x by negative b over 2a. We found the y by plugging that result into the function. There's the vertex. So this is, we show the calculations here. 3 times 1 squared minus 6 times 1 plus 4. Negative 3 plus 4, 1.
Where did the negative b over 2a come from?
Where did it come from?
Yes.
Well, I would have to look at it and figure out how to derive that again. But for now, it just comes from, I told you. I don't love that, but also there are some things that you can use them, you can apply them, but to understand them, it would take just more of a lengthy discussion. Kind of like you can use a car, and with what?
How does the engine run?
But how does the engine run? It'd be ideal if you knew how the engine ran, so that you could work on it if necessary. But you still can drive it.
It explodes.
It explodes. Yeah. Then you should probably know what happened.
If you were so
Okay,
high.
so this is kind of a little bit like we don't really know how this engine works. We can go ahead and use it. I'd like you to know how it works. It's just a matter of do we have that much time? And sometimes can you even understand the explanation? So right now it's a little of both. It's a lengthy explanation, which I'd be glad to explain some other time. But for now we do have access to the vertex. It's at 1, 1. Which way do you think it goes? Do you think it goes up or do you think it goes down?
Up.
Down?
I'd
Down.
say up.
You think up? Why think up?
It's above positive.
What's both positive?
Or
You
is
couldn't
it-
possibly be at 1, 1 and then have it go down like this?
Oh, I get what you mean. Oh,
Sure. Well, it's going to be in a couple quadrants.
Wait, maybe down because the negative 6.
Maybe down because of the negative 6. Turns out no. Let's see. Well, it all comes down to this guy right here. X squared is going to be the biggest. Right? When you plug in a number for x and you square it, it's going to be bigger than just x itself. Right? It's going to be the biggest. So this guy will determine which direction does it go. So what did we say before? That number in front of x squared? So what was it that made it point down?
Negative.
It was negative in front of the x squared. Let's see. What do we see in front of this x squared? Positive. So what do you think? Up. And it will, yeah, it will open up. Let's verify that. Let's plug in some values for x. You might ask, well, which x values do we pick? Do you want to pick 1? You could pick the x value of 1. Let's put 1 here. You could. It'd be a waste of time though, wouldn't it? Why is it a waste of time? Because you already did it. You already plugged in 1 and it gives you 1. So now a good choice for x would be something close to the x value you already have. Something close to the vertex. 0, 2. These These are both close to the vertex. What am I drawing here? What's this called again?
Dotted.
Line of symmetry.
The line of symmetry. Yeah.
Alright.
That is a line that divides it perfectly in half, and it's the same on this side as on that side. The line of symmetry. So 0, comma, what? How do we figure out what this is? You follow the equation. You put 0 in there. That's 0. That's 0. What's left? 4. What do you think you'll get when you put 2 in? So you think 6?
No.
I think 4. Why would it also be 4? Over here, 0, comma 4. Right, what's this called? The line of symmetry. So if I reflect this over, where will it land? And symmetrically, what x value would this be then? This is 1, right? So these are 1 apart. So if we go another 1 on the other side, what's that? 2. This is 1. This is 2. So we should also get a 4 just by the symmetry of a parabola. We can make sure that we do. We can do 2 squared is 4 times 3 is what? 4 times 3? 12. Then 6 times 2? 12. So we get 12 minus 12. 0 and we're left with 4 again. How are you all here today?
I'm awesome.
You're on. Odd?
Is that all just 4.1?
So how come awesome means that same thing as awful? It's like the opposite of what it should mean.
It's a good point.
No.
Here, I want you to do 23 in your notes by yourselves. I'll come around and help you out.
22? 23.
23.
What's the answer look like for these? What's the 22?
Okay, you have Google Drive.
Yeah, we're gonna graph.
Oh, it's gonna be a graph.
Look at the Google Drive symbol.
Yes.
Look at that drive.
By the link.
Oh, yeah, there it is.
Google Drive.
Oh, 4.1, right? Or 4.2?
4.1.
Label the vertex.
4.1, number 23.
Oh, wait. I should probably look at that.
Yeah, you probably should.
It's got it in the sidewalk. It's got it in the sidewalk. Yeah, it has to be something.
Wait.
So that you got it in the sidewalk. Yeah, because you look at it.
Number
Yeah.
negative b over 2a. Dial. Number 23. Start by writing the number 23. And by looking in your book for the number that matches that number and writing the problem that's next to that. pick it up with you from here. Again, we do negative b over 2a to find the x part of the vertex. Negative b is 8, so there you go, negative 8. Over 2a, a is negative 4, 2 times negative 4, so we get negative 8 over negative 8, or positive 1. Okay, and how are we going to find the y? Plug it in, right? So we get negative 4 times 1 squared plus 8 times 1 plus 2. Right? This is negative 4 plus 8. So negative 4 plus 8, that's 4. Plus 2, 6. Should we expect when we plot some points, should it go up like this? It should. When we just had a discussion about how to decide if it goes up or if it goes down.
But it's negative.
But it's negative, so yes, this is negative, so it should go down. This is the vertex. Remember, whether it goes up or it goes down, this is the vertex. It's either the bottom or the top of the graph, depending on if it goes up or if it goes down. So let's say we suspect it's going to open down. We're very confident. We know it's going to go down because there's a negative in front of the x squared. Now we're going to pick some values of x that are good ideas. A bad idea for x would be like negative 8. That's way over here, and as we looked at before, that's going to be a very large value. If it's very far away from the vertex, it's going to get really far away. So let's stay at 0 or 2. We should expect to see what? The same, right? It's got this symmetry. We should see the same thing on both sides. So we put in 0. 0 is going to be the easiest thing to plug into standard form because what happens to this? 0. What happens to this? 0. We're left with just the constant. So we should get 2 when we put 2 in, right? Because of symmetry. We put in 2, negative 4 times 2 squared plus 8 times 2 plus 2. This is 4 times negative 4, that's negative 16. 8 times 2, that's positive 16. That's 0 plus 2 is 2.
How'd you get the negative 4, 1, and all that to the y?
How did I do it?
Oh, where do you get
The one.
This 1? From here?
the whole y?
This? From here? Just plug 1 into that, right? Plug in 1 for x, find out what y is.
So why is there just a 1?
Here?
Negative 8 divided by...
This? Because we did negative b over 2a, and that comes out to be positive 1. Okay. That one is where that came from. This one goes here. Small function. Stop. Okay, so we have 0, 2, we have 2, 2, and were we right about that negative 4? What did that negative 4 tell us? Opens down. Down. Okay. So, to graph a quadratic in standard form. What are we going to do first? Find the vertex. What's there? And then the first part, finding the vertex. Right. So we're going to find negative b over 2a. So we're going to take that. F of negative b over 2a. That means take this, put it into the function, and then do what needs to be done. Square, multiply by 2, add 6 times that thing, minus 3, whatever needs to happen. And you have your y value. Okay? And we'll plot the vertex. What else can you plot right away once you plot the vertex? Yeah, you can decide whether to open up or down. We can actually draw something on the graph. A line of symmetry.
Do we not have graphs?
No, you don't, but it does help you remember that you should have this reflection. It's not part of the graph, right? This is my point. It's just an aid. Vertex actually is part of the graph. It actually, when you put in, like, this point is part of the graph. When you put in 1, you get 6, right? But you don't get this line from that function over there. So no, it's not a necessity, but it is helpful. You can say that this is optional. Okay. Okay, so to this point we have a vertex and a line of symmetry, but now we need to get an idea of how steep it is, we need to do what? Yeah, we can get an idea that it should be steep, but we should have some more like points to draw through, right? So plot some more points. And not really far away from the vertex. We're going to stay near the vertex, so some points near the vertex. Okay. Now we'll go to 4.2. No longer looking at standard form. Yep. Alright. Alright. Let's pay attention now. Before we talked about how you can take x squared, you could multiply it by something. You could add something to it. And I'll leave it in that form. What did this k do? Raises and lowers it, moves it up and down. What did this a do?
Makes it skinnier, wider.
Skinnier, wider. It affects the steepness. Steepness. Whether it be more steep or less steep. And what? And maybe a vertical reflection. If it's negative. But it's in control of that, of the vertical reflection or the steepness. And the steepness both. This one up or down. Okay. So what did Tyler ask about earlier? If you could
Cubit.
side to side, how would we move it side to side? What did we say? We talked about that. We said we should. No, not cubit. If this affects the output, right? You get the output, then you add something to it. That moved it up or down. So what if we add something or subtract something to x before we square it? And that will have a horizontal moving effect.
That's right.
What do you do?
Oh, you're back. Did I have really cracked it in there? Was it cracked?
Yeah. Oh no.
Ready?
I'm laughing at you.
Okay, so what do you think this will do if I say x minus 2 and then square it? If our suspicion is that it's a horizontal thing, what do you think it'll do?
It moves that way.
Okay, let's see.
To the left.
That. So parentheses, x minus 2 squared, L squared. And what's parentheses on this side too? Okay, there we go. So the suspicion is that we move to the left too. Let's see. What happened?
Oh, I went to the right.
We moved to the right.
Oh, it's cheating.
Okay.
So if you were negative 50. Wait, move calculate things. Move this so I can see the green.
Oh.
I think
Wait, don't turn.
if you were to
it's like upside down McDonald's.
Orthodolia, crazy.
Or-
Forest, two lines.
But how come they
No,
put
it's
curve
curved.
intersect at the axis?
They don't intersect with the axis. They intersect right there.
And they intersect at the axis?
They could. What can I do to one of these to make sure that they cross the axis?
Plus
Three,
two.
not
It's +2 or -3.
Ew.
All right. So this moved it to what?
Right.
The right. Moved it to the right too. Okay. So that's a little bit counterintuitive. But if you think about it, you'll let's see. You'll find the vertex. You'll find the vertex wherever this winds up being 0. Right? This here would be 0 where we find the vertex. It's like right in the center when the thing that you square is 0. So what would cause this to be 0? What would you plug in for x to cause it to be 0? 2, right? 2, it moves to 2. The vertex moves over to +2. Not over to -2. When I put -2 in here, I get -4. Okay. This moves it right 2. So what's this gonna do? -5 gonna
To the right.
to the right 5.
Zoom.
And can you move it to the left? 6
Plus.
plus 6. Oh, I think I just realized what that thing right there was doing. It's recording the screen right now. Yes.
Oh, yeah.
All right. So this moves up or down. This affects the steepness and it maybe possibly vertically reflects it if it's negative. And this moves it horizontally. It's really old, guys. So tiny. Okay. This is called vertex form because it makes it quite easy to find the vertex. How far does it move horizontally? This much, right?
How many?
H much. However much H is. And it moves up K much. Okay? So if the whole graph moves to the, yeah?
So right now you're finding the vertex, correct?
Exactly, yeah.
Okay.
This is the vertex.
Yeah,
That
that's
actually was my point. So, yes, the vertex is HK. If everything moves over H and up K, or to the left H and down K, depending on where H and K are, then so does the vertex, and the vertex starts at 0, 0, so if it moves over an amount of H, then the X part of it is H, and if it moves up an amount of K, then the Y part is K. So let's put that to practice. Right? Let's look at number number 8. Okay, we're gonna find the vertex. It's very
One
simple.
negative.
What's this gonna do? +1 moves it where? To the which? How much?
Negative.
To the left. 1. So the vertex will be to the left 1, -1. And down 3. So our vertex will be at -3. Finding the vertex is very simple with the vertex form -1, -3. It's gonna open up or down. How do we decide?
Oh, it's gonna open. Oh yeah, it's gonna open down.
The 2, right? The 2 will be the number that, if you were to multiply this out, you would get x squared out in front. You would multiply it by 2, you get 2x squared and a bunch of other stuff. But 2x squared would be out in front. And so the +2 means we know it's going to be opening up.
Mr. Strickland.
Yeah.
So
side of this equals 0, that x value that you used to make it 0 is the x value of your vertex.
Okay,
That's what that was about.
okay.
So since you have to put -1 in there to make it 0, -1 is your x value of your vertex. What are some good choices for x values? 7, 6,
4.
1 is a bit better.
Yeah.
Maybe 0 is good. It's right next to the vertex. It's right there. 0. Right? So we put in 0, what do we get? 0 plus 1, that's 1. Squared is 1 times 2. It's 2 minus 3. What do we get? -1. Where else should I get a -1? That's because parabolas have symmetry. So at -2, we should also get a -1. 0, -1, -2, -1.
Whoever came up with parabolas was really frustrating. There's so much stuff to remember. You'd have to come up with all that stuff.
See, they didn't look at it as memorizing. They looked at it as, I understand why.
They're a mathematician and they're gonna be smart.
Not smart,
Okay,
just
so
curious.
did they get paid to figure out these formulas?
No,
probably
it was
not.
like Plato.
Not Plato?
No, Plato was a philosopher actually.
He's a mathematician as well.
No, Plato wasn't like a fine.
And the platonic solids. Anyway,
He was the student.
Okay, we don't care anymore. And you're wrong. No?
Oh wait, we're listening.
there always should be listening. Number 7, if you look at number 7, what's the vertex for number 7?
-2,
Almost. It's like 75% right. The -2 is going to move it how?
right.
Right. 2. The vertex is 2, 4. The right 2, up 4, 2, 4.
Wait, why would it go to right? It's negative.
Okay.
Oh.
How do you make
He wasn't here.
silly Levi?
How do you make this 0? You put it in
Negative
-1
1.
with x.
And then
And that's what the X is.
I don't know what I'm doing.
Oh,
Oh,
the X
I
is
get it.
And then also for that one, what makes that 0? 2 makes it 0. Okay. Now, we're going to look at another form called intercept form.
another warp form.
It's the last one. The last
fun.
form. The last form. We're going to graph this guy, and I'm going to help you to see why. Why is it called intercept form? To be more accurate, we should probably call it x-intercept form. We're talking about x-intercepts. If you remember what those are, that's great. If not, we'll talk about them again. Here, let's do it this way. The cloud is just is us remembering stuff. Okay, so I've drawn this graph.
I think cloud is patented.
How many x-intercepts does this graph have?
Four.
Infinity.
4.
And one.
Guys,
We see
4. We see 4.
What? 4.
It intersects the x-axis 4 times.
Oh.
3.
It's like 5.
Because it what?
Intercepts the x-axis 4 times.
Yes, it intercepts the x-axis 4 times. Here's a 1, 2, 3, and a 4th x-intercept. That's what an x-intercept is.
Three
Why
variables.
0?
Four
X could be
is
that.
Huh?
So why 0? X could be this.
Right. That's the whole point. Is that when you're on the x-axis, when your graph across the x-axis, or when your function, well, let's see, we'll get to that. When you're on the x-axis, say this is -6. -6 comma what? 0. Right? Because on the y-axis, you don't go up, you don't go down, you stay where you are, that's 0, a y of 0. What about here at -4 comma 0, also 0, -1 comma 0, and
Positive
6 comma 0. My whole point here is that on the x-axis,
All y's are 0.
all y's are 0. Okay? So let's say that this was the graph of some function f of x equals whatever it is, right? Some rule, some equation over there. When we put in -1 into that, what are we going to get out? What are we going to get? We put in -1, get out 0, right? X comma y. Put in x, you get out y. When you put in 6 into here, you do all the stuff, you'll get out 0. Okay? So on the x-axis, you put in something for x, and what do you get out for y?
0.
Right. Put in something for x, get out 0. Okay? So if we wanted to put something into this function and get 0, can you quickly see what you'd have to put in to make the whole thing equal to 0?
Yes.
What?
-1 and 3.
-1 and 3 will both do this, right? It has 2 zeros, it has 2 x-intercepts. If you put in -1, you'll get -1 plus 1 times -1 minus 3. Well, -1 minus, or -1 plus 1 is 0, times, does it even matter what I put in these parentheses? It could be -4, which it is. It could be 17, it could be 1,000,000. If I multiply it by 0, what do I get? 0. Likewise, if we put in a 3, we get 3 plus 1 times 3 minus 3. It's got to be 0, because this is 0, and 0 times anything is 0. So x equals -1, and x equals 3 are two places we will find on the graph. What will we find?
0.
X-intercepts, yes. The words we use. Vocab. You pick that up, please.
Why don't you pick up your trash? You just threw it over.
Kyle, can you pick up that trash? -1, you'll find an x-intercept. 3, you'll find an x-intercept.
Yeah.
Sure.
Yeah, we're talking about like.
You have to go to the ER because it's time.
What the ratio?
Yeah, ratio. The chance of him hurting his
The
country.
ratio of
Alright.
painkillers from the body weight.
So, we have these two x-intercepts. Where will the vertex be?
In the middle.
In between.
Alright.
How far in between?
Right split.
Right smack dab in the middle. Right?
So right.
Where is right in the middle of these?
1.
1. Yes? 1.
C. Yes.
Okay. Like if we took so if we take the two x-intercepts, call this one P, call this one Q. We take P plus Q and do what? Divide by 2 to find the middle, the halfway point. Okay, we get 3 plus -1 over 2. This is 2 over 2. This is 1. So exactly, yes, that's where we should find the vertex, somewhere on that. That should look more like a line of symmetry dotted on that side.
Here's the thing, every time they're
Every time. we're going to find out where it is. We know its x value is positive 1. How do we find that y value? Huh? That's how we found the x value.
Plug it in.
1. Plug it in. Plug in 1. We get 2 times.
Two.
2 times negative 2. Negative 4. It's what? It's 1 negative 4. Yeah. I thought you said negative 4.
Figure that negative 4.
Yeah.
What?
How'd you get it?
Well-
It was negative 2. I'm really.
Well, we have the x is 1.
Uh-huh.
How do we find the y value if we have the x value? Okay, so we plug it in, we get 1 plus 1,
Oh.
and
Okay.
this one.
I got you.
Okay. The last thing, which is actually quite a bit of review here. If we have a function like this, and we can divide it like this. And we want to take it from, what form is this in? X-intercept form, yeah. Because it's very easy to find the intercepts because we know that 5 will make 0 and negative 3 will make 0. But that's not the point here. The point is we want to take it from intercept form to standard form. Standard form is ax squared plus bx plus c. So, any ideas on how to get it from that form to this form?
Foil.
FOIL. We multiply both parentheses together.
Because he's smart.
Right? So, FOIL, what does F stand for? First. So x times x is x squared. O? Outside. 3 times x. Inside. Negative 5x. Last.
Yes, I got it right.
Negative 15. Then we combine like terms.
X squared.
Okay, really briefly. What form is this in?
Standard.
No, that's standard form. Intercept.
Vertex.
Vertex form. No, there is no mx plus b for Atlas.
Vertex.
All you gotta do. What does square mean? No, means multiply it by itself. Itself is x minus 2, so multiply x minus 2 times itself.